Now let us discuss about non-homogeneous recurrence relation, or this can also be called as inhomogeneous recurrence relation. Here we have two types of recurrence relations: homogeneous or linear recurrence relation. Second one is non-homogeneous or inhomogeneous or non-linear recurrence relation. Homogeneous recurrence relation means this right hand side value. Let us assume that right hand side value is f of n. Homogeneous or linear recurrence relation means this right hand side value, that means f of n must be 0. Whereas non-homogeneous or inhomogeneous or non-linear recurrence relation means this right hand side value, that means f of n is not equal to 0. Here we have different cases in non-homogeneous recurrence relation. In this video we are focusing on non-homogeneous recurrence relation for constant value. That means the right hand side contains a constant, a number. Let us solve two examples based on this model. First example, solve the recurrence relation an plus 2 minus 5 into an plus 1 plus 6 an equal to 2. So here that order is not specified. Like in the second example we have n greater than or equal to 2. So we can directly say that it is a second order recurrence relation. But here order is not given. So we need to find the order. We can find the order like we need to subtract the minimum subscript from the maximum subscript. Here what is the maximum subscript? N plus 2. What is the minimum subscript? N. So we have to subtract n from n plus 2. So this n will be cancelled. So the result is 2. So that means this example is a second order. Here the right hand side is not 0. So this is a second order non-homogeneous recurrence relation. So first you need to write that point. So the recurrence relation is a second order non-homogeneous recurrence relation. The general solution for second order non-homogeneous recurrence relation is an equal to an power h plus an power p. H means homogeneous solution. H means homogeneous recurrence relation, homogeneous solution, whereas P means particular solution. So first let us find out the an power h. So what is an power h? So that is nothing but homogeneous solution. We know about homogeneous recurrence relation. F of n value is 0. So now in order to compute an power h, we have to substitute 0 at the right hand side. So now the recurrence relation will become an plus 2 minus 5 into an plus 1 plus 6an equal to, we have to substitute 0. Why? Because here this is nothing but homogeneous recurrence relation. We know the formula for the characteristic or auxiliary equation. We know that the characteristic equation or auxiliary equation is auxiliary equation. So this is second order homogeneous recurrence relation. So we will get quadratic equation. So the first one is nothing but here the constant coefficient is 1. So we can write it as k square minus, here we have coefficient as 5. So that constant is 5. So minus 5k plus 6 equal to 0. So this is the auxiliary or characteristic equation. So here now we need to find out the k value. So if you do the addition then 5, if you do the multiplication then 6. So that means minus 3 minus 2. So minus 3 minus 2 means minus 5, minus into minus means plus, 3 into 2 means 6k square. So if you observe the first two terms, k is common. If you observe the second two terms, minus 2 is common. So what are the values now? k1 equal to 3, k2 equal to 2. k1 equal to 3, k2 equal to 2. So now the roots are real and different. So here the roots are real and different. Real and different. So we know the formula for the general solution when the roots are different. So the general solution when the roots are different is an equal to a into k1 whole power n plus b into k2 whole power n. So an equal to a into what is k1? 3. So 3 whole power n plus b into what is k2? 2 whole power n. Let us assume that this is equation number 1. So now we have an power h. So now we need to compute an power p. So now let us compute an power p. Let us compute an power p. So what is p here? P is nothing but particular solution. So an power p is nothing but, let us compute an power p. So an power p is nothing but, here this an is nothing but an power h. Why? Because this is nothing but the solution for this homogeneous part. Whereas the solution is nothing but an power p, particular solution. So this right hand side value is nothing but this an power p value, an power p equal to 2. So which is a constant. So 2 means constant. So here we have different cases. If we have constant, then the general solution is an equal to, the general solution is a naught. The general solution when we have constant is an equal to a naught. Now we need to substitute an value in the given recurrence relation in order to obtain this a naught. Okay. So here what is an plus 2? Here in the right hand side we have only a naught. We don't have an. Suppose if we have an, then an plus 2 will become an plus 2. A capital A n plus 2. An plus 1 will become capital A n plus 1. But here at the right hand side we don't have nth term. So now an plus 2 or an plus 1 or an is nothing but a naught only. So now what we have to do? Substitute an in the given recurrence relation. You need to write that point. Substitute an in the given recurrence relation. So what is an plus 2? A naught minus 5 into what is an plus 1? A naught plus 6 into what is an? A naught equal to 2. So 6an minus 6 minus 5 means 1, 1 plus 1 means 2. So 2a naught equal to 2. So this 2 will be cancelled. So what is a naught? A naught is nothing but 1. A naught is nothing but 1. So now we need to find out the general solution for the homogeneous recurrence relation. So what is the general solution? The general solution for the non-homogeneous recurrence relation. So what is the formula for non-homogeneous recurrence relation general solution? An equal to an power h plus an power p. What is an power h? A into 3 power n plus b into 2 power n. Next, an power p. What is an power p? Initially an power p is nothing but a naught. What is an power p? Initially the value is nothing but a naught. So this an power p is nothing but that particular solution value. Initially the general solution is a naught. Why? Because here we have constant. So plus a naught. So this is nothing but an power h. This is nothing but an power p. Next we have computed a naught value. So an equal to a into 3 power n plus b into 2 power n plus what is a naught value? After computing we got a naught as 1. A naught as 1. Let us assume that this is equation number 2. This is equation number 2. So if a naught and a1 values are not given in the examination, then we can stop the process now. But in this problem a naught and a1 are given. So by substituting a naught and a1 we have to derive a and b. So let us derive a and b by substituting a naught and a1. So what is a naught value? What is a naught value? A naught is nothing but 1. A naught is nothing but 1. So now in place of n we have to substitute 0. A0 equal to a into 3 power, what is n value? In place of n we need to substitute 0. A into 3 power 0 plus b into 2 power, in place of n we need to substitute 0. 2 power 0 plus what is a naught value, which is already computed, that is 1. So what is a naught value? 1. So 1 equal to anything power 0 is nothing but 1. So a into 1 means a plus b into 1 means b, a plus b plus here we have 1. So what is the result? A plus b equal to, we can write as, we can move this one towards this side. So 1 minus 1 will become 0. So this is, let us assume that this is equation number 2 is over. Let us assume that this is equation number 3. Now what is a1 value? a1 equal to minus 1. So now in place of n we need to substitute minus 1 value. So a1 equal to, what is a into 3 power, in place of n we need to substitute this 1. 3 power 1 plus b into 2 power 1 plus 1. So a in, what is a1 value? Minus 1. Minus 1 equal to 3a plus 2b plus 1. So we can write this as 3a plus 2b equal to, if we move this one towards this side, then it will become minus 1 minus 1, that is nothing but minus 2. Let it be equation number 4. So now let us write here, for space constraints I am writing this, I am erasing this portion. So now we have this equation and this equation. So let us multiply the second equation with 2. So this 2b will be cancelled. We will get a value. Okay. So let us write the first equation now. So 3a plus 2b equal to minus 2. So this is our equation number 4. Next, let us multiply equation number 3 with 2. Then we will get 2a plus 2b equal to 0. So subtract. So minus minus minus. So this will be cancelled. So 3a minus 2a means what? A. So a equal to minus 2. So the result of a is minus 2. So now we need to have b value. So how to get b value? We know the formula for a plus b. A plus b equal to 0. So what is b value? B equal to minus a. So now b will become, what is a value? Minus 2. Minus of minus 2 is nothing but plus 2. So what is a value? A value is minus 2. What is b value? 2. Now let us substitute a and b values in equation 2. So now the general solution for this problem is an equal to a. What is a? Minus 2 into 3 power n plus b into, what is b value? B is nothing but 2. So 2 into b into 2 into 2 power n. So plus 1. So this is the general solution for the first example. So likewise we have to solve the second example. So now let's see the second example. Yeah. Solve the recurrence relation an plus 4an minus 1 plus 4an minus 2 is equal to 8 for n is greater than or equal to 2 with a naught equal to 1 and a1 equal to 2. So here, if we observe here, so this is which order? Here what is the maximum subscript? N. What is the minimum subscript? N minus 2. So let us subtract the minimum subscript from the maximum subscript. So n minus 2 minus maximum is n. So here this n will be cancelled. So minus of minus means plus 2. So this is nothing but second order recurrence relation. Here the right hand side contains 8. So 8 means it is not a 0. So we can say that this is second order non-homogeneous recurrence relation. So the general solution for the second order non-homogeneous recurrence relation is an equal to an power h plus an power p. So first to compute an power h. So here this h is nothing but homogeneous solution. So we need to substitute 0 at the right hand side. So now the equation will become an plus 4 into an minus 1 plus 4 into an minus 2 is equal to, we have to substitute 0 in place of 8. So this is the equation. So now we know the auxiliary solution or auxiliary, we know the characteristic equation. The characteristic equation or auxiliary equation is, auxiliary equation For second order homogeneous recurrence relation is, here the constant is 1, so 1 into k square, here the constant is 4, so 4 into k plus here 4 equal to 0. So this is nothing but direct formula. So what is the formula? K plus 2 whole square equal to 0. So what is k value? K value is minus 2 comma minus 2. Here the roots are real and equal. Here the roots are real and equal. If the roots are real and equal, then what is the general solution? An equal to a plus bn into k power n. So an power, this is nothing but this homogeneous part only. So an is nothing but anh only into a plus bn into what is k value? K value is minus 2. So minus 2 whole power n. So let it be 1. So now an power h is computed. Now we have to compute an power p. An power p. So what is an power p? An power p is nothing but particular solution. That is nothing but 8. So 8 is nothing but constant. So if we have constant at the right hand side, then the general solution is an or an power p equal to a naught. So this is the general solution. So now the complete solution will become, what is the complete solution? An equal to, what is the formula? An power h plus an power p. So here we need to write here, but for space constraints I am writing here. So an equal to an power h. What is an power h? It is already computed. A plus bn into minus 2 whole power n plus what is an power p? This is nothing but an power p. That is nothing but a naught. So now we have to substitute an in the given recurrence relation in order to obtain the a naught value. So let us do that. So now here if it is a constant, then by default for every subscript we will get a naught only. Why? Because here in the right hand side we don't have nth term. So now an or an minus 1 or an minus 2 is nothing but a naught only. So now we can write it as a naught plus 4a naught plus 4a naught equal to 8. So 4 plus 4 means 8, 8 plus 1 means 9. So 9a naught equal to 8. So we can say that a naught equal to 8 by 9. So now substitute a naught in this equation. So then the solution is an equal to a plus bn into minus 2 whole power n plus what is a naught? A 8 by 9. Let us assume that this is nothing but so the equation number 2. Suppose if a naught and a1 are not given in the examination, then we can stop the process now. But here a naught and a1 are given. So by substituting a naught and a1, we have to derive a and b values. So what is a naught value? A naught equal to, what is a naught value? 1. Now substitute 0 in place of n. So now the equation will become a naught equal to a plus b into what is n value? 0 into minus 2 whole power 0 plus 8 by 9. What is a naught value? A naught is given as 1. So 1 equal to a plus b into 0 is nothing but 0. A plus 0 is nothing but a. Anything power 0 is nothing but 1. So that is nothing but a plus 8 by 9. So directly we got a value. So a equal to 1 minus 8 by 9. So if you do the LCM, so 9 minus 8. So what is a value? A value is nothing but 1 by 9. So now we need to compute the b value. So in order to compute the b value, what we have to do? We need to substitute 1 in place of n. So a1 equal to, what is a1 value? 2. So substitute 1 in place of n. So a1 equal to a plus b into 1. So that is nothing but b only into minus 2 whole power. What is n value? 1 plus 8 by 9 plus 8 by 9 minus 2 whole power n. What is a1 value? 2. So 2 equal to, so here we have minus 2 whole power 1, that is nothing but minus 2 only. So minus 2a, minus into plus means minus, minus 2b plus 8 by 9. So we can write it as minus 2a minus 2b equal to 2 minus 8 by 9. If we move this 8 by 9 towards this side. So then if you calculate the LCM, 9, so 1 9s are 9, 9 2s are 18. 18 minus 8, so that is nothing but 10 by 9. 10 by 9. So here already we know about a value. So minus 2 into what is a value? 1 by 9. 1 by 9 minus 2b equal to 10 by 9. 10 by 9. So now we need to compute the b value. So let us move 2b towards that side. So 2b equal to, let us move 10 by 9 towards this side. So minus 2 by 9. If we move towards this side, then minus 10 by 9. So minus 2 minus 10 means what? Minus 12. So minus 12 by 9. So this is the result. So 3 3s are 9, 3 4s are 12, 2 2s are 4. So what is b value? So b value is nothing but minus 2 by 3. So what is a value? 1 by 9. So now we need to substitute a and b in this equation. So now we will get the general solution as, what is a value? A value is 1 by 9. So 1 by 9 plus, what is b value? Minus 2 by 3 into minus 2 whole power n plus 8 by 9. So this is the general solution for this problem. So likewise we can solve any problem very easily if this is a constant. So likewise we have 3 more cases like n square and 2 power n. We will discuss all those examples in the upcoming videos. Please like the video, subscribe to the channel, as well as share the channel with your friends. Thanks for watching.